Hello, my name is Andy Catlin. I'm here from the City University of New York's Master of Science and Data Analytics program. CUNY's MSDA program is internationally ranked, project-based, quantitative, and one of the most affordable data science programs. It's 100% online, and if you're interested in learning more, please let us know. I'm very pleased to be able to introduce Charley Plotly, who's an application engineer at Plotly and a student in our MSDA program. The Plotly software, when students presented in class, the next week 6 more students were presented. So it's really a viral, great way to do data visualization, and here's Charley.
All right, thank you for the introduction. As Andy mentioned, I'll just be going through the Plotly platform, how it integrates with everything that, if there are current students on the webinar, it integrates with everything that you've been learning throughout your program. And if you're just, coming from externally, checking out the program, these are a lot of the tools that you will learn during the MSDA program. So this fits in very nicely with that ecosystem. So just to continue with the introduction, I'm Charley Ferrari, and I started my MSDA program in the fall of 2014 and scheduled to graduate this December. And the reasons I chose it, pretty much a lot of what Andy mentioned. It is very easy to fit in with a full-time job. I was working at IHS at the time I started, IHS and then Global Insight before that, if IHS acquired Global Insight back in 2008. So if anyone's heard of those companies. My background is I worked with the economic data platforms of IHS. So IHS is an economic research company, and Global Insight in particular is an economic forecasting company. So we sell economic research, and I worked really closely with economists and helped with our data platform. So it would be a lot of data retrieval platforms, a lot of econometric platforms. So eViews is probably the most well-known out of everything I've worked with there. And so that's really where I, fell into, my interests in data science. And, it started out learning a lot of open source tools on my own, so R and Python, mainly starting with R. I started learning on my own. And in the beginning, it was a desire to, begin learning the open source alternatives to a lot of, the more closed tools I was working with at IHS. And as I got more and more involved, I came across the MSDA program from CUNY, saw that it, fit in really nicely with my career goals, with the sorts of skills I wanted to learn, and it, so far has, I remember just starting out, it was just, I learned, so much more than, in the previous year and a half of just playing around on my own. So it's definitely been worthwhile for me. And in March, I ended up joining Plotly, and it was, largely thanks to the MSDA program. I ended up learning a lot of the skills that I use on a daily basis. A lot of it is, also what I've just gained from my experience at IHS. And being an applications engineer, it's a client-facing engineer position. So my day-to-day job, it's a lot of building proofs of concepts for clients. Plotly, you are able, as you'll see, you're able to use it in a lot of different ways. And a big part of my job is kind of analyzing what a client is looking to do, trying to see how Plotly fits in. It also, that also works with many demos, so that'll be a large chunk of what I do as well. And by the way, if anyone does have any questions, feel free to ask them. I'll check the I can't actually see the chat since I have this in full screen, but I'll be sure to check that at some time. So just to start out broadly how you could interact with Plotly, you're able to interact with it either through the workspace, and this is just uploading your data using CSV format from Excel and building your graph from there, or you can interact with it directly via APIs. We have official APIs in R, Python, and Matlab. It's all built on a JavaScript REST API, and you are able to use it just purely from JavaScript as well if you're looking at things from more of a development sort of perspective. And as you'll see, it ties in very nicely with a lot of these tools. In terms of the chart types, this is just an sort of example of a lot of the different chart types that you could create with Plotly. Plotly was actually founded by by two physicists, and essentially they were actually coming from the Matlab ecosystem, and they were just looking for a way to really collaborate on what they were working on. And so you could see the scientific roots of Plotly in the chart types that we have. So you could see a lot of 3D charts, a lot of statistical charts, different scientific charts here. So we'll get into different tools that you could use Plotly with, and I have an example actually using a project from the MSDA program that is being used in Python. But this is just an example of using Plotly in RStudio, and you can see the hover on the code here. I didn't want to just have the full screen of the code, but you could see that you do have two ways of using Plotly, and this is true in RStudio, true in Python and Matlab as well, that you could either use the native graphing language within whatever tool you're using. So here ggplot is what's native in R. And you can't see it here, but there's essentially a ggplotly command that would take that ggplot object and be able to render it into what you see on the right-hand side there. So this is one thing, if you're familiar with RStudio, you could see that that's the viewer tab that you're looking at there. It's not the plot tab, so it actually is fully interactive within RStudio. So that's one way of using Plotly with any of your favorite environments, is you could just use it fully in-house. Like if I just wanted to stay in RStudio and be able to just create higher caliber visualizations, I would be able to do that totally within RStudio or within IPython Notebook or Matlab. And the second way of interacting with Plotly is the Plotly command that you could see above. In R, it does look very similar to what you see with ggplot. So you're choosing your x and y. You're choosing a variable to like this actually doesn't correspond to what's in the viewer right now, but you can see that you're choosing your x and y. You're choosing something to group by. So if you're looking at multiple lines, that's really what you would end up getting with this code. It works similarly with Jupyter notebooks. So here using Python, you could see that, and here I'm showing a bit more, delving into what the structure of Plotly is. And when we get to an example, I'll show you how all of this ties to how Plotly at its core works. So this is just sort of a preview of the code there. I'm building essentially this fig object out of both the data and the layout. So in this case, I'm only choosing a title, but I could have also tweaked the titles of the like the titles of the X and Y axis, different aesthetic aspects of the chart if I wanted to. And this graph is fully interactive within the Jupyter Notebook. So again, similarly to RStudio, you're able to work with it fully within the environment of your choice. But really, the power of Plotly expresses itself when you're collaborating using the platform. And here is an example bringing in how it looks in the platform. So in a lot of these commands, not in RStudio, but you could see it in this Python command here, that you're actually targeting a file name. And I'll show you an example how something like that works. But this kind of gives you a preview of what that what that really ends up looking like. So you're working within your environment. You're working in this case in Matlab, and you're able to then go to your organization of visualizations in Plotly and either do further editing if you're just making some aesthetic changes, or really share what you're making with other users. And all of this is built on Plotly.js, and here this is getting a bit more into how Plotly is structured. But every graph is a JSON object, and essentially the platform is taking in these JSON objects and rendering them in a collaboration environment. So here, you could. This is just sort of showing an example of how you could use this directly with JavaScript. And because it is JavaScript, it's totally web ready, and it's very amenable to working with more web development environments. So using it through Jupyter Notebooks, through Matlab, that's really more of the data science workflow. But you could also think of Plotly being used as a development aid. If you want to take a Plotly graph, be able to interact with it, you could use a JavaScript REST API to make changes with the graph and add that to a web app. So here, this is an example of how something like that would work, that you have ways, so this is in the share plot dialog, you're actually able to embed the graph as an iframe. And what this allows you to do is you could just copy and paste that, and then use Plotly.js to make changes to it. So here, this is actually this is a screen cap of the it's actually my Data 606 project that I reworked with Plotly, and I ended up using D3 just to control the drop-downs, and it's all operating off of a CSV. It's not, I don't have it tied to a database in this particular example, but you could just as easily build something that is tying to a database on the back end. But what this allows you to do is make changes, and sort of control the logic of how something like this would work. So now I'll go through some of the ways that you could collaborate using Plotly. So really, this is where the core of how Plotly really was developed. It was developed because of the need for collaboration among data scientists. So in this case, this is just an example of how someone using Plotly, someone using R, using it for different things, you could work on the same project and collaborate using Plotly. So I could use something like Python, use Beautiful Soup to scrape data from the web. In this case, this is a 3D treasury yield curve, and I could work with I could do all that work using Python, and then perhaps, I know this is the case with me, that I could more easily come up with a 3D plot in ggplot. So I might want to, work with create a simple visualization with Python and then work with ggplot to really fine-tune what I'm making. And I have a little code snippet here that shows how this works on a programmatic level. So what I'm actually doing is I'm using this PyGet figure to get a particular graph and bring in that object into R, in this case RStudio. So I could run that command, get figure, get the graph, either get the graph, get the data, you can see that as well, and then repost it to the to that existing file. So within RStudio, essentially what you're doing is taking the graph object, making changes to it, and adding those changes back to Plotly. And what this also really flows into is collaboration between data scientists and web developers. So, it started as collaboration between data scientists themselves if you're a group working on a project, but as we've, as Plotly has been, gaining more clients, what I've been seeing a lot with the people I work with is, you're working with a larger company, you have a lot of different roles within that company. You have your data science team, you have a BI analyst who's essentially looking to use a tool that a data scientist would build. You have web developers who would be sort of the ones really designing how this would work in a web interface, and all of this is done with JavaScript. So here, using this, sort of building on this example, first you have different data scientists working with different languages, being able to collaborate amongst themselves. This could be, you hand it off to your web developer, you have a finished product that the data scientists came up with, and from a web development perspective, you're thinking, we have this US Treasury yield curve, perhaps I want to add a country drop-down, be able to have interactivity, make this, I could just look at the country and get the yield curve for that country. And then lastly, you have collaboration between data scientists and non-programmers, or data scientists and, collaboration if there are changes that you would rather make in a web-based platform like this. So I know personally, if I'm working on a project, I would map out all of my variables using something like R or Python and build my visualization, the base of my visualization like that. But I would usually find, and what I find myself doing a lot of times is sending that to Plotly and then just fine-tuning it using Plotly. So adding my axis labels, adding my annotations, making any changes, other aesthetic changes that I would need to. Something like that does work very nicely with this platform here. And this is also just showing that you could also connect with SQL using this environment. So I'm going to move to an example of how this would work now, and I'm just going to quickly check the chat to see if we have any questions. And if anyone wants to ask a question, like I said, feel free to ask away. So here, the example that I'll go through is actually from from a class last semester, 643. So some of you may recognize the example here, but this is using, this is a pairs trading example that'll show you how you could update something on Plotly from a Python environment. So just to show you what the organization looks like, if I go to my charts, I have my home screen. This is essentially where you're able to save visualizations. where you have visualizations that are shared with me. And you can see here just a lot of things that I've been working on. You have the main feed. So over here, this is just a selection of what people have been, what people in the Plotly community have been posting. And so in this way, it's really a sort of a more social collaboration experience. So you have this main page, you have the your own environment here, and this is sort of as day to day what you'd be interacting with more, whether you have your own visualizations here, when you're sharing with other people, etc. And as I mentioned as well, this is totally workable from within Jupyter Notebook. So here I last plotted this, and I'm able to fully interact with what I have here from Jupyter Notebook. But if I want, and really where the value comes in is if I wanted to make a change to what I'm graphing here. So this was actually the first project from that class where we're measuring co-integration between two equities. And for this sort of showing it here, I'm just bringing in data from a source called Quandl, which has pretty good financial data, and then doing calculations and essentially highlighting where the pair is co-integrated. So these bars are actually, and I have that happening over here where I'm appending, where essentially regions where the pairs have been trading in a co-integrated way. So that's really what you're seeing over here. And working with, so first of all, working with this, the way that I have this set up, I could very quickly go in and make changes to what I'm looking at over here. So if I want to look at, here, if I want to compare IBM and, let's say, Microsoft. So I could enter in those, the way that I have it set up, I'm just entering in those tickers and it'll bring in that data. And then when I replot it here, you'll see that I have it pointing to a specific file name. And that's this right here. So once that runs, it sometimes takes a while to pull the data from Quantl. I actually might have had that ticker wrong. And I hate that this happens during a live demo. It always does, but I'm just restarting this here. And I'll try different tickers because I think I ended up getting the wrong ticker for Microsoft there. That's what's killing that program there. So here, let's just say I'll change this to Tesla and Zillow. So that might not make as much sense since they're not related. Usually you would want to pick equities from the same industry. So here, let's just make sure that that runs. And when I replot this now, you'll see the new graph show over here. But more importantly, when we're looking at the graph that I have saved over here, once that gets off of busy, I'll be able to refresh this and get that updated data within Plotly. And right now I'm just using it to sort of toggle between different equities, but something like this, if you are using it professionally, it could be used in terms of getting updated data. So even with this, especially with this sort of data, you could, have a script that's updating your data every day with the most recent data. You're monitoring something. You could have things update in that way, and really sort of from that environment tie into wherever you have. So here you can see the new data that came in. And you could have that tie into wherever you're using it. The JSON object you could see right here, and this is really the core of what Plotly is based on. So you could see that you have a data and layout object, and there's a lot of layout here because we added a lot of bars, but usually your layout will be things like background color and things like that, and then of course your data. So you have different information about the names of the traces, and that's controlling what I'm viewing as I hover over it. And of course there's documentation going over everything that you have here. And what you're able to do is share something like this with this embed command and end up with something like this. So this is the dashboard that's the remaking of my 606 project, which is essentially an explorer for Bank of England company visit scores. But you can see that I have some pretty complex logic that's controlling what I'm looking at here. So each of these drop downs, I'm looking at a different aspect of the data. So here I'm looking at different sectors. Here I'm comparing to sectors. Looking at the different dates, so that ends up affecting what we're seeing here. And all of this logic is spelled out in JavaScript, and all of these graphs are being pulled in directly from Plotly. So this really gives you an idea of the end-to-end workflow that you could have, starting from data science environments that that you really get familiar with as you're working through this program, and then moving on to collaborating with web developers, collaborating with analysts who would be using the tools that you're building. So I'll just check one more time if anyone has any questions. And if anyone does, like I said, feel free to ask away. Then I just have a couple of more slides to go through here. So if anyone has any questions.
Charlie, one question is, how many languages does Plotly integrate with? Someone who came in a little bit late.
Mm-hmm. Sure. Right now, there's officially it's our Matlab. There's an unofficial hook into because Plotly.js is open source. And there have been a couple of hooks that have been built. And actually, Julia, I should have added as a more official language that is supported. There's also SPSS support, and I believe someone in the open source community wrote something that connects to Scala, and so it is open source, and there are new connectors being built all the time, but it's but the three main are Matlab, R, Python, and Julia. I would add to that as well.
Can I throw a couple more questions at you from the audience?
Sure. Yeah, of course.
Is Plotly similar to D3.js?
Yeah, it's actually an abstraction of D3. So all of these graphs are D3 at their core. It's essentially just built using this language instead of pure D3.
And Mohammed asked if you could maybe compare Plotly with something like ClickView or Tableau.
Mm-hmm, that's so. As I've joined Plotly, like a lot of the demand that we've been seeing, like it started out in really scientific computing, and a lot of the demand we've been seeing has been coming from the BI space, and it's been, so in that space, like you do have a lot of people who are using ClickView and Tableau. The way that I would compare it is Plotly is just more open than a lot of these tools. So something like Tableau, that's what I have the most experience with. And essentially it works as an end-to-end pipeline. You have to have Tableau hook up directly to your database. You do the and you're able to totally in-house control your relationships between the data, control how you're able to take data from two different databases, relate them together within Tableau. And do a lot of the sort of building out your visualizations from there. So, in Tableau it becomes more end-to-end. With Plotly, it's just open. So, in terms of what you're able to use Plotly with, like anything that Python, R, Julia, Matlab connects to, you're able to use in Plotly. Like if you have data that's in MongoDB, you would be able to connect to it using R, plot it into Plotly, have someone else take it out in Python, and work with it there. So really, it's that openness that I've that I found is the key differentiator between a Tableau and Tableau, ClickView, and Plotly.
Thanks, Charlie.
Mm-hmm. Anything else?
Not at this point.
No. Okay. So I'll just finish up here with a couple of notes on the directions that we're heading. And it's thinking about it. There we go. So right now, the current iteration of GUI building is a tool called Dashboardsly. And you can see here that Dashboardsly ties into your Plotly account. It lets you just pick which visualizations you would like to add to a dashboard. You're able to publish it, and using the workflow that I was describing before, you're able to continuously update these dashboards. You're able to do it either via the REST API, so have a cron job that updates things on a regular basis. You could have and I didn't mention this before, but we do also have a streaming API, which would be able to work with Dashboardsly. So if you are looking at something second by second, actually there's a good example of this over here. Sort of looking at the various APIs. So looking at a dashboard that's made like this, you could see a couple of these examples are using the REST API, but this example right here is using the streaming API. So essentially the rule of thumb there is like second by second sort of updates. You would use the streaming API. The REST API, that's, I would say, like up to a resolution of like 5-10 minutes, something like that. And so that's the current iteration of building GUIs. And what we're working on is a tool called Dash, which is a tool that's going to be more focused on building sophisticated GUIs. So at the moment, if anyone is familiar with Shiny from R, this would look very familiar. It's it's built on top of Flask, which is the web development environment of Python, and you're able to essentially totally control HTML elements using Python, controlling drop-downs, and then using Python to tie that to the data. And so right now it's it is starting out in Python, but it's really going to follow the kind of ecosystem that we have with Plotly, where you'll be able to You know, if you want to stick with a drag and drop interface, you'd be able to do that. If you want to combine that with some programmatic logic, you would be able to do that. Doing it in R or Python, you would be able to work with multiple languages and, you know, really build sophisticated GUIs. There's also, this is being worked on with a company called Formidable, and it's a essentially Plotly presentations, so it's going to be totally tied with with Plotly visualizations, and similarly to what you saw with Dashboardsly, it will you know, be totally interactive, totally online, you know, a new way of sharing presentations. And one of the larger projects that we're working on in collaboration with Domino, and I'm not thinking of the other company that we're working on this with, and all these are open source. Interact is going to be a multilingual desktop-based notebook. It's using the Electron.js backend, and it's you know, essentially it's going to be built around Plotly from the ground up. So you're going to be able to have those visualizations in your notebook, similarly to what we were seeing with Jupyter, and have that seamlessly tie to your Plotly account. And lastly, we're currently integrating with Mapbox to provide more geospatial, some more geospatial integration. So here, this is actually a Mapbox Mapbox data coming in, and you know, you're able to graph data on top of it. And I also have an example of you know, this is sort of going back to that dashboard example that I built using Bank of England data, where you could have different visualizations interacting with each other. You could click on a Plotly visualization and in this example, see which counties it refers to when you're hovering over these data points. And that's it for what I have for my presentation. I just realized I forgot a slide with my contact information, but I'll make sure if anyone wants it, I'll provide my email so that you could ask me any questions afterwards. And of course, if there's any questions coming in, I'd be glad to answer them now. So Andy, is there any
Thank you, Charlie. No new questions. Really nice presentation. Thank you very much. Exciting product.
Thanks a lot. I'm glad. You know, I mean, it's really exciting to work here. It's really exciting to you know, see see how much this ties into everything that I've been learning at CUNY.
Great. So I'm just going to hold for maybe 2 minutes just to give anyone any time to send in something really fast while they can. And then after that, I think we're set.
That's my email if anyone wants to get a hold of me.
Charlie, for someone who's experienced with a language like R and Python, and they already know a graphics library like ggplot or matplotlib, what would you say is the learning curve for Plotly?
The learning curve is, like especially for ggplot, I found that it's pretty smooth. And what's really helped me in terms of you know, getting a handle on the Plotly language is really playing around with the graph once I have it in the platform. So I'd be able to make changes to my graph. You know, if I see an interesting graph, I would think, you know, how is something like this made? I could just go into it. I could view it and see, and then look at the JSON idea of it's being built there. Like here. Oh, where is it? Oh, so here I'm actually using a library called Cufflinks, which, if you're familiar with Pandas, you're able to, essentially have your data frame and just if you run .plot, you're using matplotlib to plot your data. So that's what I'm using here. But you could see it in R when I'm building. And here I'll get into this over here. With R, it's very similar to ggplot, where you're sort of defining your AES essentially in the function. And with Python, it relies very heavily on dicts. So here, if I go to just some of our documentation for an example or two, you could see the structure of how these are built, and essentially it maps very, it maps pretty easily to what you're seeing in the JSON object. So here you could see that you're entering in a dictionary object to the go.scatter function, and that ties to essentially what we're seeing here, where you have your data, you have your list of traces if you have multiple traces, and then your layout. So that's really how I got past, how, like, in my experience, like, the learning curve has been. But also, as I mentioned, I could, if I'm working with something, I could use ggplot and just run this command right here. So here I'm defining that as its own object. And if I'm running ggplot, it'll just totally render what I have with ggplot. And similarly with Python, you could grab something in matplotlib. It's it's plot_mpl, I believe. And that'll just take that fig object that you would create using matplotlib and render it in Plotly. So, you have the option of not even learning the, Plotly syntax. You could just stick with the syntax that you're used to.
Thank you, Charlie. One last question, which is, will the link to the presentation be available? This maybe is a question for Darian and Charlie.
Mm-hmm. Yeah, and I could provide that to, I'll make sure that that's available.
Yeah, we actually recorded this. So we actually recorded this webinar. So in the next few days, I'll be posting that up, and I can share it with you, Charlie, and as well as doing a follow-up email with everyone who attended. Yeah.
Cool.
Okay. So I think that about wraps this up. And
All right. Thank you so much for everyone attending.
Thank you. Have a good one.